Hey everybody, this is Ryan Robitaille. I wanted to show some more things in DataRabbit. Yesterday I made a video with going over a lot of the Clojure script features. Today I wanted to do more focused on the nREPLs and actual Clojure features, which I know a lot of people are more interested in. So, start off here, I have a blank canvas. Oh, we'll make a new canvas. We'll hit here, new canvas. There you go. All right, so we have a new canvas here. So I'm gonna get rid of the library browser here with Shift Q, because I don't really need that. And I have my palette here. I'm going to drag in a server block. So by default, it connects to the built-in nREPL that my pedestal app runs. Let's see here. So I have Rabbit running, and see starting embedded nREPL server at 8888. You can see here there's an option in the config file to connect to an additional nREPL, but we're just going to use arbitrary connections, and that'll make more sense in a second. So we have our built-in REPL here, Java 11 Clojure 1.10.3, and I'm also running two more REPLs down here. One, I've got some Incanter libs loaded up with an older version of Clojure, and the other one I have some TechML dataset libraries loaded with a newer version of Clojure. So how do I access them? Well, the built-in REPL is always going to just use that embedded one with no hinting here. But if let's drag in two more. So these are both using the same embedded REPL. But I'm going to go here and I'm going to pass a comment hint. So this one I'm going to hook up to the Incanter REPL and say, okay, use this one to 42999. And you can see Clojure 1.9, it's connected to that one. And if I go to the data science one, down here, 32999, so, Clojure 1.11. So as you can see, we're connecting to three, different REPLs here for different use cases. Something I didn't mention in the previous video is with the editor. So real quick, let me just do something else here. So the REPL, first of all, the REPL box acts differently than the Clojure script box. Because the Clojure script box, essentially, it evaluates the entire form and then outputs a single output of whatever is last, right? So almost like you'd think like a do block, right? Does some stuff, but that last statement is the one that actually gets output. With, REPL connection is a bit different, because I can say, print line, this is a line, and then I can say, we'll do string hey, and then maybe, a little math. And when it gets run, I actually get the output of everything that's, outputtable, essentially. It's all run in the same namespace, but, it gives me multiple outputs here, which makes things interesting because, generally, let me pick a layout. So I pick a layout, and then I can choose here what I want. Again, I didn't go over this yesterday, so apologies. So if I pick this layout, and I say I want to have the code here, and I want to have out auto here, which I used yesterday, out text, whatever. The out auto is running kind of like the Clojure script one does, right? It picks the last thing outputted and sends it out. But I have access to all these values. So if I wanted out one, I could just click on this guy and say, give me out one auto. Or maybe I want to see hey, and maybe I want hey to be down here. Which makes it kind of interesting because I have access to multiple, streams out of the REPL. As long as the order in the index doesn't change, these can all change independently. And what was I going to say? They can all change independently, and they will go to their, the respective blocks here, which is pretty cool. Not only that, but if I send this guy out here, and we're sending this 81 out, I can actually, and let's say that's not 81, let's say I want this to be, whatever. I can say, okay, this is my output, this is my whatever, but I can say, you see how when I hover over here, it highlights the old server block? I can actually click here and show that as well as my in auto. So just a little note about this crazy editor, that can actually pull from itself or things it's connected to, which is really helpful, and I'll use it in a practical way in a second. So we got nREPL connectivity, so now we can do some kind of cool stuff. Let me just go here to nREPL experiments. So here we have a couple things. I have an incanter test from their from the README on their GitHub page. I'm doing some stuff here where I'm taking the bytecode of the image instead of actually like linking it because I was worried about, you know, accessing web roots outside of Rabbit, but ignore that. But basically, you know, I'm doing their thing with a sine wave and a randomized, you know, bar chart from the tutorial. But I'm doing something kind of cool here. I have these two sliders, which are obviously Clojure script sliders, connected to, you know, their own atoms, and then pushing the result of that atom into this incanter, which obviously it can't access the namespaces of the atoms in Clojure script, but I can send them there by basically having an input value in this, right? Which is actually just parameters right here. So get parameters in 1, get parameters in 2, and this is being injected into this as it gets executed, which is kind of cool. It's one of the things that I like about this flow concept is that, yes, we can use atoms, and atoms will operate as they should within namespaces, both on Clojure script and Clojure, like respectively. But if we want to, you know, if we want to cross the streams, we can use, you know, these same in and out parameters to do so in a fairly easy way, which is pretty cool. This is some tech ML dataset stuff, also tutorial from the website, doing some Titanic machine learning, which is kind of neat. You can see this is the REPL output, which is basically like what would be printed. And here we have the actual data return. See, the interesting thing, this is split. So this is the REPL full, this is the data that I'm receiving, and this is the output. So you see if I'm printing a data set, it does just like it would in a REPL. But, you know, Rabbit can't do anything with this, right? I need the actual data. So that's where we have these come in, right? This is the actual data sets that were produced out of here. I don't know if these will render, but let me see. So if I had the code over here, and we have this guy, and put him here, and then this guy, put him here. Yeah, so this is the actual data, and you see it's being recognized as a row set, which, as I said yesterday, is, you know, a bunch of uniform maps in a vector, which I used for, you know, SQL, you know, SQL queries and, you know, database stuff. So not only do I have the, we'll just put it here, the REPL output. So not only do we have the printed output we would get at a regular REPL, but we have access to these objects. I think I did map to sequence here somewhere to get these to, where is it? Yeah, map sequence reader. So we have kind of some interesting stuff going on. What else we have here? Escape unselects things, by the way. Yeah, simple shell stuff. This one's kind of cool because this is another. I got this data off another one of the tutorial sites. I think that's the most straightforward thing to look at. This one is just pulling some stock data, showing it same way. But what's cool about this is I'm taking the data out of this Clojure REPL, bringing it to Clojure script in its own block, and then since it's in Clojure script, I can just send it to more blocks and visualize it just like it was any other data set. You know, the Clojure script block doesn't care where the data comes from, it just sees it as data, right? And then kind of like what I was showing yesterday, I can also, notice the atom, I can also say, all right, well, if I click this, you know, send the value to this block, and then that block splits it out into its, you know, its constituent parts, which you can do all kinds of interesting stuff with. Something else I didn't go over yesterday, apologies for the rambling of this video. If I have a block, right, by default, you see down here, display as out auto on canvas, and flow output, which is the output that comes out of it, right? So if I had, you know, if I wanted to see this as text, right, without my fancy, this little fancy, like sugary display, if I wanted just as text, I can also direct the text down to this and display as text on canvas, and you see the canvas will render it that way, which gets kind of interesting if you want to do some more strange things. Like, for example, this one shows the atoms that are on the page, the two sliders from the incanter representation, and I don't know where this one is. Oh yeah, this is the click action from over here, right? So if I click this guy, that one should change. This is just another panel available. If the namespace you're in sees their atoms, you can kind of enumerate them here and at least see what their values are. But what's even better is that if I say, let me go up here and say, I'll say diff ones, atom, if I create an atom here, yeah, because I'm a little slow today. So if I create an atom here, you'll see this. It now recognizes there's an atom in this particular block. And that's useful because, you know, let's say I'm doing all kinds of stuff here and, you know, the output of this, where is it, out auto, is this Clojure script thing, and then maybe I'm doing like some, you know, it's hard to type with this microphone in front of me. All right. You know, if I'm doing stuff and I'm mutating it, you know, let's say I'm doing some work here where I'm doing stuff with atoms, but it's not actually the output. The slider is a great example. You know, the slider updates its own atom, but its output of the slider is literally the slider rendering. But in this case, I want to say, okay, this is my atom. Drag it over here. I can see it's you know, an empty map, which is probably a bad example. We'll go back to test. So I can look at my atoms in individual editor panes here. I can also say, hey, what I want to do with this atom is send it out as the output of this block instead of the output of this block. So now we'll do, we'll go out auto back in here. Get rid of this guy. So it says Clojure strip again. So it says Clojure strip as its output, but if I dragged it out, it would be the value of the atom, which is super nice and flexible. I mean, it's the only reason I can get this to work, right? I have an atom for the slider. The slider itself, you know, mutates that atom. Oh, it's going from integer to float. Interesting. Mutates that atom. And then, see down here, dref slider 2, it sends that atom out to the descendant block, essentially. So if we go to here, you know, that's how they communicate, which is pretty cool. You know, it's funny. I had a script for this video, and I totally like went off it like 5 minutes ago, 10 minutes ago. Anyways, on to more interesting stuff. All right, more REPL shenanigans. All right, got a server block. I'm just going to use the built-in server REPL, not the other ones, because I know that the built-in one has a bunch of JDBC drivers in. So if I have a JDBC connection, I'm just going to use this one here. This is SQLite one. This is an actual SQLite database that comes with the distribution of Alpha 1. So if the server recognizes a JDBC connection, it'll automatically try to connect to it and try to get the metadata, which is cool, which is helpful. But I was like, well, if I have the metadata in my block, I can do some more interesting things with it. So we have this, you see popped up here, another editor pane potential, out JDBC. This, I'll drag this to my canvas, like I showed in the last example. So this will actually take the metadata and render it as, you know, tables. And then, well, shit, if you have the tables, you might as well do something with them. So if I take one of these tables and drag it out to the canvas, it says, oh, we're going to do a select all SQL query to that table, because that's essentially, you know, that's what you kind of want to do. So now we have this, you know, select all, select star, just generated query. And since I have the metadata of the table and the metadata of the query, well, why not have a little simple SQL, you know, pivot table tool, right? Because we're looking at data and we're slicing things up. Sometimes you just want to click through things, get some ideas, you know, decide whether they're good or not. So here I'll do, let's do year. This is actually a lot of data, so we'll do throw count in there, and we'll get rid of the all, so it's just count by year. All right, so we have it aggregated by year, and that's kind of cool, you know, just nothing too exciting there. If I wanted to filter this, actually, let's do. I showed in the other video that on click is kind of important in some of these interactions. So if I click on one of these rows, you can see on the left panel of pills, it actually knows the values now. So if I just wanted 2019, I could say, oh, well, year is 2019. I'm going to drag that to the where clause since it's a field and a value, right? And then it would give me, hopefully, just 2019 as an example. But we're going to do something a little fancier here. Okay, so back to our count by year. And there's a lot of data in this database, so maybe not great for an example since it takes a few seconds to actually get the SQL back. But anyways, I digress. All right, so we have our years here. We'll go to bring up my clicked row thing. We'll say we want a data viz. I'm going to click on one of these rows in order to tell it what the fields, because basically it's looking at an empty vector. And clicking on this, it sees the map of this row, which there tells it, oh, okay, this is the kind of data we're working with. So I can say, all right, these are the kind of things we can draw now. So I'm going to do kind of like the example yesterday, year by count. We're going to make you the X, and we're going to make you sum. It doesn't really matter since it's already summed up, but Y. So I'm going to say, okay, I want the bar. We're going to drag the bar out here. It runs the parent query again just to make sure that we, got our ducks in a row. Okay, cool. I have my bar. I'm not going to mess with it, but obviously there's a whole, configuration map here that you can mess with. You see it creates this atom by default, which is the one that gets the on-click event. So you see how it's the outline here is white and output is white? Because what it's outputting now is nil. It doesn't output anything. But if I click on a row, it changes to pink because now it's outputting a map of the values that I clicked on. We're not doing anything with it at the moment, but that's what it's for. So, okay, let me take this output map. All right, so cool. We got, color, string, nice. I could just, cut it up inside the block here, but since this is a demo, I'm going to say, all right, well, what I really want is this year integer. So we're going to drag that out there. Okay, cool. So now as we change, as you look at different years, it changes that value. Okay, cool. Well, what can we do with that? Well, let me make another query to the database. I'll put it over here. And this value, what I want to do is show it in a kind of a row set way, or kind of just make a map with the field name. So if it's year, and that's the value of the year, cool. I do that because if I then take this map and drag it into another generated SQL, it will realize, I'm just going to get it to run again. It adds in, let's look at all maps that are coming in, use them as filters. Again, this is not probably code you want to use in production, but it's getting us to that next step, right, where we can do some things. So now if I go back to when I click on a bar, it downstream controls this filter, right? So if we're making a dashboard, you can already see how we get some, back and forth. So let's do something cool with this one. Let's say we'll do count, and we'll do group by occurred on date. Get rid of this all. Wait till it comes back. Okay, that's cool, but I want just the date, and that's not in the data. So let me just open the code, and I'll just edit it real quick. I'm gonna do some cut and pasting here because I'm lazy. All right, we're gonna get rid of the time. So just chop that off, and we're gonna make sure that we're grouping by that new value, and we should have just the date. Should be in the upper word. Okay, cool. We got the date. Make that a little more slim and tasteful. All right. Again, we're gonna go back to our clicked row. Oh, another thing about the clicked row that I didn't mention is that back to the code. You see, clicked row is one of these things used in editor panels, right? But it's also something that you can do if you want to say, hey, when someone clicks a row in this data set, just send it. I can drag it to output flow, and that way, if you look at the map on the output here, without having a actual coded atom, this is kind of using it internally. You know, it'll send whatever the row is to the next block if that's something that you need to do in your flow. Anyways, that's not what I was trying to show here, but I just thought that was cool. All right, so let's get rid of this guy. I'm going to go back here. I want to make sure that you're outputting. I want to make sure that we're outputting our regular output and not the clicked row. Yeah, because it didn't run again. Okay, we're cool. All right, so what was I doing? Yes, all right. So now we have this. I can say count occurred on date, chart X, chart sum. It realizes a date, so it allows me to do this calendar option. This is just really an excuse to use Nivo's GitHub calendar. Cool. Then we have, oh, it's because I'm limiting it to like 45 rows or something. Yeah, well, that's silly. And then, you know, right, so now we're cascading that through the flows and generating a new calendar. And, you know, might as well, clicking on these rows, as always, you know, populates an atom that is then sent downstream from this thing. So, you know, what do they say? Turtles all the way down. So kind of a cool thing you can do with SQL and JDBC. And the neat thing about this is that, you know, to get me to this state, I really didn't type that much code. It just, you know, just one substring for the SQL. But, you know, I like the idea of like keeping things flowing, right? You know, get me to that point where I know what it is that I'm building, know what I'm doing, and then I go back and I can tweak it all and make it all nice. But like just getting my thoughts out there and just generating starter code, I find to be really helpful. You know, I don't want to have to stop and write something I've written 10 times before. Just give me something, and then I'll figure it out from there. So what else do I have here? Simple SQL, peaking, calendar. All right, just two more quick things. So in one of the built-in in one of the shipping flows, I have this flow called Subflow Test, and it's just a straightforward little React like picker list, right? It updates an atom, as you can see, you know, instance atom, sends it to this block and displays it. Over here, you can see, you know, this is literally just me looking at the atoms, and this is literally just me printing the namespace. I have this special flow namespace, which is like a dynamic namespace based on what flow you're in. And that is important in this instance because it means we can take this flow, not lose track of the atoms, and then put it in other flows as like an instanced subflow. I know, sounds weird, but all right. So we have our list and we have our display. Cool. Let's go to a new flow. All right. So there's a subflow block, which allows you to configure a subflow, but an easy shortcut to do that would be to say, here's my subflow test flow, right, in the selector. What if I just drag that down on the canvas? Okay, so here's my subflow operating inside the canvas, which is cool, but not exactly what we want. You see here we have a block list, and we have block input and block output. This is so I can take blocks in this current flow, send the value into that flow, and then get one of their values out. In this case, we have no inputs here, but this is my item, a string. We want that to be the output because that's this, you know, cheese string. So if we add that and we say, okay, cool. So now we have, you know, cheese. So if I manipulate this flow, we're now sending that value from that flow to this flow. But there's more. So now that we have access to this flow, as you see down here, these are the actual blocks that are in that flow. And I can use them as editor panels. So this is my list, let's switch to this view. This is my list, is my actual UI. And, you know, this is the item is. So now we've kind of almost turned this subflow into kind of like a mini Rabbit application that operates inside. Actually, let's say we don't want to look at this here. Let's say I want the output to be, yeah, we'll just put the list down there. So kind of interesting, right? And you see the flow instanced, random number. So what I've done is, see, this is the flow room right now. This is what we're using. I've created an instance of this flow that's running all this, so I can keep the state separate from the original flow, right? So if I were to add another one of these, another subflow test, it has its own state, and you can see here now we have two different. Let me unselect that. Yeah. These are our two instances of flows we're using inside this instance. And if I wanted to, I could go into one of these instance flows and see the state there. And you can see, yeah, it's part of Subflow. This is just an instance. When those get deleted, this gets deleted. But really kind of cool. It's the same flow as Subflow Test, but it has its own state for the sake of, for the sake of these subflows. And there's still work in progress here. Obviously, one of the issues is if I'm linking these together with React, React won't react if it's not being rendered. So there's some stuff I got to work through there. But it's really kind of cool because you can create blocks that do a lot more complicated things, reuse them, and not have all that logic be in your main flow. But again, work in progress. But very cool. Instance subflows was not something I thought would be in release 1, but it works for the most part. Okay, one last thing. Yeah. So let's go back to this guy. So another work in progress feature is Overseer. And Overseer is kind of like a profiling tool for the blocks. Not only profiling, but being able to visualize the render time. It doesn't work for a server yet. And I think it's only showing like the last eval render cycle, but you go into hit tilde to pull up there's little settings here, and we're going to say enable block profiling. Oh, also, yeah, the lines. It's kind of cool. I don't know. I like the curved the most, but some of these are kind of neat. Anyways, I digress. So, all right, I turn block profiling on. So I hit tilde to get rid of the settings, and now you can kind of see, average milliseconds. Some of them don't quite work right. That's why I say it's a work in progress. And you can kind of see the calendar is pretty expensive, 25. Let me just change some stuff here. Yeah, it's not counting the server time, because if I use the server time, it would just blow out everything, because obviously it's going to be the slowest part of the application. All right, so now we're profiling some stuff, get to the average. Cool. Let me go to a complicated dashboard. This is a much more fleshed out version of the Clojure script one that I showed in yesterday's video. So profiling makes things a little bit slower too, obviously, since it has to log all that. Let me go to the dashboard, just so I can get some re-renders. Noi. So this is dynamically, querying SQL to get this data and then displaying it, in this dashboard. I have a couple of interesting things here, like I can click on the individual sightings and then get, the information of the sighting. I have a Vega-lite down here drawing some maps, which is pretty cool. Like Texas. Again, I'm just doing this so I can generate some profile data. Yeah, I didn't show this yesterday, but I'm doing some Vega-lite. You can see down here in the bottom that it's showing me, the profile data since it's been on for a little while. This one's only rendered a couple times, so it only has a couple. Again, Vega-lite. I should do more Vega-lite stuff. It's so much more terse than Nivo is. I do love Nivo though. Okay, cool. So now we have generated some profile data. What can we do with it? Well, one cool thing we can do with it is let me go back into settings and say color block backgrounds as render heat map. So now we can kind of see a heat map of like what blocks are expensive to render and what blocks are not. Again, a little ridiculous, but kind of cool to see. Let me go back to the dashboard here. Select you, turn on preview mode. And it gets the average of the execution time, or the render time. So it's probably not going to change a lot since we already did a whole bunch and they've kind of like settled on these averages. But anyways, I think it's kind of cool. Let me go here. Every 10 minutes or so, the profiling data gets purged out of the database because you know, otherwise we'll crash Chrome. So yeah, we turn off profiling, go back to nice speedy mode, and yeah. Anyone hit me up on Slack or Twitter, anything, other questions, and I think that's good for today. Cheers.